In this first section, I'm going to show you the VM that I'm spinning up so that you see the complete and transparent process. For this, I'm using Vagrant to make this easier. And I'm also going to use VirtualBox as my provider for Vagrant. And you can see I have these versions here. When you do this yourself, you'll want to make sure you have recent and compatible versions. The next thing I'm going to do is make myself a directory that I can put all of my things into when I do this. And I'm also going to show you that we're using just a plain Ubuntu VM. We're not using anything special. And we're going to start it up. So that's the whole process. That's how easy it is for us to start up the VM. And we're not going to use any special tools. So we're not going to use kubelet. We're not going to use the kubelet bash script or anything like that. We're going to do all of this by hand to show you that this is something that when you remove all of the fancy flags and features, that Kubernetes really is kind of simple in concept. And we're going to take all of the raw binaries from the Google storage where Kubernetes is stored, and we're going to put them onto our machine and then start them up. So once this machine is finished starting up, we're going to SSH into it and gain root privileges. So you'll need root privileges in order to do this lab so that you don't have to type sudo in front of everything. So it just helps to change to the root user. It keeps a lot of problems from happening. You can run Docker not as root, but that's a complicated process that we're not going to cover today. We'll wait one more moment. Alrighty, and let's get into our virtual machine, get ourselves root privileges, and then the first thing we need to do, because if we try to download Docker, which is the first thing we want to do without updating our package repos, we need to do that. And then also, it won't hurt us to upgrade. You don't have to do that to run this lab, but this is a pretty quick process if you're running a recent version of Ubuntu. All right, so the first step in this whole thing, getting all of the stuff for Kubernetes running, is to install Docker. And that's really easy, just like that. So you can see that we're using apt, our package manager, in order to install that. And we're not going to do anything special with Docker at all. So no special flags. We're just going to leave the default settings just the way they are because they'll work for us. Now, of course, if you're going to be running in production, you're going to tweak a lot of things in order to make it run exactly the way that you want. So let's go ahead and go back to the slides to show you what we have so far. So we've created our virtual machine and we've set it up. And this box that you see here represents our virtual machine and our operating system. You can also see here that we are currently SSH'd into our VM so that we could install our things. In addition to that, we've also installed Docker inside of our VM, and we can now create containers on it. So in Kubernetes, this is a node component, and it is the container engine that we have chosen. So this container engine, as you will see throughout the lab, is the nucleus. It's the core and the focal point of everything else that we're going to set up today. If Kubernetes is all about abstraction and governing of containers and their management, this is like the farmer on the ground that the control plane will manage, who will actually create processes contained on the machine, and it will do this in order to achieve the goals of developers and operators who manage the cube. We talk about the difference between a runtime and an engine in some other training, but for now, let's just consider them to be the same thing. And let's go back to our terminal. So I want to go ahead and download the Kubernetes binaries and extract them. So again, it will be hard to type along with me during this demo, so we're going to send you out the instructions after it to all of you who can today. And you can download these binaries directly from the Google Storage API. And there's a lot of different ways that you can download Kubernetes. There's a lot of different ways that you can install it. And if you want, you can download the Kubernetes tarball, and with that you'll get all kinds of helpful scripts and tools. But since all we're going to do is, with our bare hands and no tools, just implant these binaries into the machine and set them up and show you how they work, then those binaries are all we need, and we're just going to download those. So we're just going to download, for example, the kubectl binary, the kubelet binary, the kube API server binary, and then we're going to extract those. And that can sometimes take a few seconds because we have a lot of binaries to extract. So we'll just give that a moment. And then what you'll see is we're just going to go into the folder in there that contains our binaries, and then we're just going to move them into their new home. So let's go in here, and you can see here we've got all of these things here, and we just want the core Kubernetes binaries here. So let's take these, and I'm going to copy this command, paste it here and show you. We're moving kubectl, kubelet, kube API server, the kube controller manager, the scheduler, kube proxy into user/bin so that we can access them from our path. All right, let's go back to our home directory, and then just to show you that the installation of these binaries worked, we're going to call on kubectl, and we get a response. Ta-da! So next, I also want to remove all of these things. So I have a clean working directory. I'm just removing the folder I extracted and then the archive that I downloaded. And we have our binaries installed. So the next thing that I want to do is install the kubelet and show you the kubelet in action. And the first thing that I need to do is to create a directory for Kubernetes manifests for the kubelet. So I can put pod manifests in this directory, and kubelet will start pods that way without even needing any of the other parts of the kube. And this is what is called standalone mode on the kubelet. So I'll show you exactly what I mean. This command right here, let me go here. This command will start the kubelet with just one flag, pod manifest path. And that will point us to the manifest directory we created. And then everything else, we're just running this on all the binaries because, first of all, we want to pipe our standard output into a log so that we can see if anything is wrong. And then we also just want to run things in the background, and that's what we have there. So you can see that this command is extremely simple. And if you've provisioned Kubernetes for your company before, usually you have 10, 20 different flags on kubelet, and the configuration can get really complex. But as we're going to show you today, when you boil everything down to the core needs of container orchestration and Kubernetes and how it works, it's actually fairly simple. So I'm going to check this process and just make sure we see it there and everything looks good. And then I also want to check the logs here, and everything looks good. You can see that we're running our kubelet in standalone mode because we have nothing else in our cube. So let's go ahead and make a file in our manifest directory. And this will be a Kubernetes pod that is extremely simple. You can see here that we're going to create this file in etc Kubernetes manifest. It's going to be called kubelet test, and it's going to be really, really simple. So this is our pod here. We're just downloading Alpine, and then we're just running a really simple bash command to echo Supergiant every 15 seconds. And that's it. We don't need to do kubectl create or anything like that. So if kubelet has been set up properly, it will start running, and kubelet will pull this directory by default roughly about once every 20 seconds. So while we give kubelet some time to do that, let's return to our slides and see what we have so far. There we go. So let's take a look at where we are right now. So since we have just installed kubelet, we are one step closer to our kube's completion. Kubelet is a node component, just like the container runtime, which is responsible for facilitating workloads on the kube. And its primary purpose is to talk to the container runtime to tell it when and what to run. And as you saw, it can run without a Kubernetes control plane, and we'll see that even more when we return to the command line. So what kubelet allows us to do looks really simple at first, but it's very powerful. So kubelet creates this standardized surface for containers, which it can do across hundreds of different types of machine, it can do it on a lot of different operating systems, a lot of different clouds, and all kinds of different variations in environment. So it makes pods extremely portable, makes containers extremely portable, and it supercharges development. It acts as the foundation of how Kubernetes achieves what it achieves and what makes it so popular. So if Kubernetes is all about governing distributed container runtimes, then the kubelet is like the ambassador that is in the field that allows those runtimes to be governed by the control plane. So what we have done so far is we've sent a request to kubelet indirectly by creating our manifest directory, which kubelet will see. So kubelet will see that Kubernetes manifest, and then it will instruct Docker on how to create that container, and we'll end up with our pod, the P standing for pod. So let's transfer back to the lab and see if it worked. Okay, so to do that, we can't do kubectl get pods, right? Because we don't have an API server set up right now. So what we do is we just go directly to Docker and check the running containers. And when we do that, we see that, yeah, our pod has actually started. And we know that it's a pod and not just a container because we see this pods container. We talk about what the pods container is, why it exists, and exactly what it does in some other training, so we won't cover that now. But here you can see this Alpine container, which has the bash command that we passed to it. And if we want to, we can even check to see if it's doing its job. And it is. So you can see Supergiant being echoed here a number of times. If we check it again, you can see that that number continues to increase. Perfect. So the next thing that we want to do is to install and start etcd. So etcd, as you know, is the database and state store for our Kubernetes kube. However, it's not part of the official Kubernetes project. It's a third-party tool, which is why it didn't come packaged with our other binaries. So the first thing we need to do is download those binaries. You can see that we're just pulling directly from the etcd releases here. And the version, by the way, that we're using for Kubernetes, if you didn't catch earlier, is 1.9. So this is a version early enough that some best practices are not enforced in Kubernetes, and we can show you the most simplified kube possible. Whereas in newer versions, some of these practices are enforced, even though they're not a requirement for your Kubernetes kube. So we've extracted these binaries, and we're just going to move these. We're going to move etcd into our user/bin etcd right there. We're also going to move etcd/ctl, which is etcd control, to our user/bin etcd/ctl. So we have those binaries there now. And then, like last time, I like to have a clean working space. I'm not removing the binaries we installed. I'm just removing the extracted folder and the compressed archive that we downloaded. And then we're going to start etcd. So this is the command right here we're going to use. We're just calling to the binary, giving it these flags, these minimal flags, in order to help it run. And then again, piping some logs and running in the background. So let's go ahead and start it. All right. And then to check if etcd is healthy, we can use etcd control and check the health of the etcd cluster. And it looks like everything is working great. And then remember that we're checking the cluster health of etcd and not the health of our cube, because we don't actually have any components for Kubernetes connected to etcd right now. So let's go ahead and just try to get resources from our cube, just to show you that nothing is connected right now. So we don't get anything from any Kubernetes cube right now. So now it's finally time for us to install the Kubernetes API server. So before we do that, let me just go back to the slides and update you on where we are. So here you see etcd installed in this corner. And etcd, like we've covered in other lessons, is the state store for our cluster, which is why I've drawn it with a hard disk drive. In previous lessons, we've covered why state is really important. And just as a quick refresher, remember that distributed systems can end up fragmented, they can end up jumbled, people can change things that need to be kept track of in the system. And so we need some way to store that state. It's kind of like a library where the history and the maps and the information for our cluster can be stored for some other program to enforce. And etcd isn't really doing anything right now, but in order to set up our API server, we have to have etcd as a flag that the API server is pointed to. So we've gone ahead and we've done that first. So let's go back to the terminal and install the API server. This, again, is really easy. You'll see more flags on this because we have some more mandatory flags, but they're very simple. So we needed to point to etcd, like we said, and then we need to point out a couple of other things for some networking and to be able to access the API server the way we want to access it. So you can look up these flags, and they're pretty simple. And then again, we're piping our logs to a file and running in the background. Let's check the status of the API server. And everything is running great. And then again, we're going to check the logs to make sure that nothing has broken. One second. Let me fix this command right here. There we go. And everything looks great. And then we're going to curl the API server. So just to show you that this is up and running and doing its job, we're going to curl localhost 8080, which is where our API server is right now. And we're going API v1 nodes. So we're just going to check out and see if we have any nodes in our cluster. And as you probably imagined, we don't have any nodes connected to the API server right now. So we don't get any nodes back, but we do get a response from the API server. And you can see here, if we change this URL, we get another response. So if you never have, I would highly recommend spending time exploring the Kubernetes API server, because it will really tie some concepts together. So for example, every time you use kubectl, it's sending a REST request to the API server, and that REST request can be seen in the API. So you can see all kinds of things in there, and it will really kind of help you understand how the API server works and how much stuff it can do, because it can do so many things, as I'll show you in just a moment. So we don't have kubelet connected to our API server. We're going to do that in a moment, but for now, let me update you again on where we are. So the Kube API server is exactly what it says. It's a server for Kubernetes APIs. You can see that we've installed it here, and it acts as the ambassador to the Kube. It's like the central hub, if you will, through which everything else must communicate. So the API server does a lot of different things. It controls access to resources, it coordinates things, it handles authorization, authentication, admission, and it can do metrics, things like that, giving you reports on your Kube and keeping track of things. So it does a lot of things, and as a result, it's the one who is coupled tightly to etcd, and everybody else talks to etcd through the API server. So the API server needs to have the strongest access to the state in our cluster. You can see here, that's why it requires a flag to talk to etcd. So here we sent our curl request to the API server to see if we could get any nodes. So it asked etcd for information to see if nodes are listed, and we didn't see any because kubelet isn't yet connected. You can see that kubelet is still off wandering on its own. So let's fix that. So first I want to show you that when we run kubectl cluster info, we can see the API server right now because kubectl by default in newer versions is going to contact localhost 8080. But we need to set up a kube config file so that kubelet can talk to the API server when we restart it, pointing to the kube config file. So to do that, we're going to use kubectl config, and what that is going to do is that's going to change this file, the kubectl config file, with some information about how to talk to our cluster, and we're going to add a cluster to that called kube from scratch, whose API server is located here at localhost 8080. So now if we check this file again, we have our cluster, which is listed here. Then the next thing we're going to do is set a context. So we will set a context, which is also called kube from scratch, which is pointing to this cluster kube from scratch, which we have just added. So now we've created a context. And if we check this file, we see that, yes, we have a context pointed to a cluster, pointed to an API server. And then the next thing we're going to do is to set this context as our current context. We're going to use the kube from scratch context. Let's see if we go here, we're currently using kube from scratch, which is pointed to a cluster, pointed to an API server. So you can see how this gives you a lot of power to mix and match different clusters, to mix and match preferences for accessing those clusters, credentials for accessing those clusters, different users to authenticate as, for authorization purposes when you're talking to your cluster. So this file is very flexible, and in addition to that, it not only does that, but it also allows us to configure our kubelet. So we can put this kube config file. You can see if we here, it's an actual file, .kube/config. You can see it there, and it will allow our kubelet to talk to our API server. So let's run kubectl again. Now that we have an API server running, and you can see that we've got the default Kubernetes service here, which allows us to talk to the API server. And kubectl is talking to the API server now. But again, if we try to get nodes, we'll see that nothing is listed because our kubelet is still drifting out in the unknown all alone, and we need to fix that. So that's exactly what we're going to do right now. So now that kubectl is taking advantage of our new kube config file, let's set up kubelet so that it can also use the kube config file. And then this way, kubelet can talk to the API server, register itself as a node in the kube, and then be available for us to use. So the very first thing we need to do is kill kubelet so that we can resurrect it with some new information. What we're going to do is, you see we've taken out the flag to point to the manifest directory, and instead we're going to tell kubelet to register itself with the API server and to find information on how to do that in the kubeconfig file. And again, we're piping logs and running in the background. We may have to run this command a couple times because sometimes it fails. You can see now it's running successfully. And then just to double check, we see it's running happily here. And then if we check the logs again, get some new logs, and we don't see standalone mode anymore because now we're connected to a Kube API server. So check this out. Now, if we run kubectl get nodes, we see that our VM is showing up here. Again, we're running 1.9, and our kubelet has registered itself. So when we say node in Kubernetes, what we're talking about is a kubelet. So like you saw in our diagram, we'll show you our diagram again in a moment with updated information. The whole entire purpose of Kubernetes is to run distributed container runtimes. And who represents those runtimes in a way Kubernetes can talk to it? It's the kubelet. So when someone says node, we're talking about kubelet because kubelet is the node that is registered in the API server. So one more thing I want to point out is if we run docker ps to check containers, we don't have any anymore. Remember that pod that we put in the manifest directory? Well, that manifest is still there, but like we said, we're no longer pointing to the manifests. We're only taking instructions from the API server now. So let's go ahead and create a pod using only the API server. We're going to call this pod kubetest, and unlike our last pod, it's not going to run a bash command. We're going to run nginx. But this is still a very simple pod. All it's going to do is run nginx, no special configuration. We created that file. You can see here, kubetest.yaml. And then we're going to create this. The pod was created. And then the next thing I want to show you is if we check this, our pod is still pending. And we can watch it all day for all of eternity, and it's never going to get scheduled. And the reason is because we don't have a scheduler. So you can see how the Kubernetes component ecosystem is forming and coming together and how each component is serving its purpose. We have an API server to tell kubelet, to start pods, but we don't have a home for this pod. We need somebody to decide where the pod needs to go. You might be thinking, well, we only have one kubelet right now, so that should be an easy problem to solve. And it is an easy problem to solve. But the problem is that Kubernetes is designed as a distributed system to facilitate distributed kubelets. So we need to have a scheduler to decide what kubelet should run what, where that pod needs to go, which is why this pod is stuck pending, because we're waiting for a scheduler to inform us where it needs to go, whether or not there's one node or 1,000. So let's leave that there pending just to show you that it's never going to do anything. And let's go back to the slides and update our diagram. So let's finally get kubectl into this picture now that we have our kubeconfig file set up. So you can see we have our kubeconfig file here, telling kubectl who to talk to, how to talk to them. And you can see here now that we're talking to kubectl, we're talking to the API server with kubectl, and we're no longer just using curl to talk to it. In addition, we restarted our kubelet, pointing it to the API server with our kubeconfig file. So now you can see it's connected to the API server and it's registered in etcd. You see, if you look closely, that a new entry has appeared for our kubelet marked in for node right here. And you can see also our old pod has disappeared, right? Because no pods are stored in etcd for creation by this kubelet. So our container has died. Pods don't get restarted when they die if they're just plain old pods with no controller backing them. And so since we've got no manifest directory, we've got no pod. But our kubelet is now successfully registered. However, all of our hope is not yet lost. So if you look again at etcd, another entry there is for our new pod that is stuck scheduling, marked P for pod. So we sent a command through SSH to kubectl. The API server took that REST API request, and we've now got a pod entry, but this pod does not have a node attached to its information. It doesn't know where to go. So let's solve that problem by creating the kube scheduler. You can see here that all that time we left it running and nothing happened because it's just not going to schedule. So let's start the scheduler and explain how this works. You can see here we've only got one very simple flag to point it to the master. You can also do this with a config file, which we aren't going to do right now. And then again, running in the background, piping our logs. So as always, I always want to check and make sure that it is running, it hasn't exited due to a failure. And then as always, I always check the logs. I want to make sure that we're not getting any unexpected errors. We're just getting a few things that we're expecting, and everything is running great. So now, if we check kubectl, we can see that our pod is now running, which is awesome. However, our pod has a short life today because I want to delete it to give us some extra room on our machine. And I also want to show you what the deletion process kind of looks like at this point in our diagram. So that was extremely simple. Let's go back to our slides and show you where we are. So now we've added our kube scheduler, as you can see here. And you can see that our pod is now pending. And since we only have one node, choosing where to schedule the pending pod is extremely easy. I put 3 nodes here just to convey the concept to you, what the kube scheduler does. But we've only got one node, so again, it's a really easy decision to make. There's no taints or tolerations or scheduling rules on our pod. So we've put the pod, we've updated this information, right? In etcd, this pod now has a node name. So pods are given a node name by the scheduler, which tells the API server what kubelet it needs to go to. And then our kubelet takes that manifest, gives instructions to Docker, and we have our brand new pod, which was scheduled by our scheduler. So as you can see, the scheduler makes it possible to do this at a distributed scale here. And then, last of all, we deleted our pod. So before, you'll notice there's no human intervention here. This is all part of the automated nature of Kubernetes. And then here we sent a manual request to delete our pod. That object was updated in etcd. See, I just removed it here to kind of give myself extra space, show you that it's gone. And then Docker was instructed to go ahead and terminate these containers that were pertaining to the pod, and that's how that works. So you might also notice maybe just a tiny change to the scheduler where we took our pod. So we had a check mark and we had a pod there. Now it's gone. I just cleaned out the example I had there earlier. So if you're wondering what kind of mystical meaning that has, I was just removing that example that I had. So let's go back to our terminal. So you might think, well, awesome, that kind of looks like a complete cube to me, right? I mean, we can create pods, we can delete pods. However, there are a couple of things that this setup can't do for us. So one of those things, for example, is connect services to pods. One of those things is enforcing replica counts for replica sets, for deployments, and a lot of other state enforcement tasks. And this is where the Kube Controller Manager comes in. I'll maybe explain that a little bit more when we get back to our diagram. But for now, let's go ahead and create a deployment that can do some more things for us and show this principle in action. So we're creating this file replicatest.yaml, and the manifest for the deployment will look like this right here. And besides all of this fluff that pertains specifically to deployments, which we won't be explaining today, we have our very simple container again. It's no different from our last pod we created. It's just going to run Nginx for the purposes of trying to contact it. And let's go ahead and seal that file and create this deployment. All right, you can see the deployment object has been created, but do we have any pods? You'll see, no, we don't. Like we said, we need a controller manager to enforce the replica counts of deployments among many other state enforcement tasks. So let's check our pods and just show you that none of these are running. So what we need to do, of course, is start the kube controller manager. And again, the flag is very simple. It just needs to talk to the API server because it doesn't need to talk to any other components. The API server is going to coordinate that communication. So we start our kube controller manager. We check to see that it's working. We check to see that no unexpected warnings or errors are there in the logs and everything looks the way that I'm expecting. And then next we're going to check our deployment. And sometimes, especially in older versions of Kubernetes, that might get stuck, the deployment might get paused. So if that happens to you, I've included instructions in the demo about how to resume that rollout for the deployment. And then, last but not least, we see that our pods, all three of our pods are now running, belonging to this deployment. You see the string here that shows that they are part of a replication controller and deployment. So let's go back to the slides and show you where we're at and explain a couple of things. So this is what it looks like for us to have the controller manager now. As you can see, it's always checking to see if the desired state is equal to the actual state. And instead of simulating the process we just went through in the terminal, creating our deployment first, I want to show you a scenario where we create our deployment after we already have a controller manager, instead of before, to show you what it will look like in actual operation. So let's pretend that we've created a deployment by sending a request to the API server through kubectl. You can see here our deployment is in etcd, but there's no pods being scheduled or running that belong to it. The controller manager notices that the desired state and the actual state are not the same. So we have a deployment. It's supposed to have 3 replicas, but those replicas don't exist. So the controller manager notices that, and then pods are lined up for scheduling. You see we have our 3 pods pertaining to our deployment. Then these pods are given a home by the scheduler. Kubelet is informed it needs to create 3 pods. And you can see that Docker creates our containers pertaining to our pod. And I just put a little D here to show you that these pods belong to a deployment because in etcd, Kubernetes is keeping track of the fact that these pods have a label that is being selected by this deployment. And you can see now that the controller manager is happy. So why does it work this way? So this is kind of another part of the secret sauce of the power of Kubernetes. So why didn't pods just come up when we told the API server we needed a deployment with 3 pods? Well, pods do not come back when they're deleted. I'll preface it with that. So remember the pod that we deleted earlier? It never came back, and it never will. Controllers take stewardship over state in a machine. So if that's confusing, we cover that in some of our other training, but let's just say for now, controllers make sure that pods are running. And if pods die that are backed by a controller, that control loop is checking the actual versus desired state of the cluster. It notices the pod is gone and then it gets replaced. So likewise, if pods are scaled up or down, the controller makes sure that those pods get created. So this is one feature that makes Kubernetes self-healing, makes it resilient, makes it really awesome for deploying fleets of pods in different fashions, whether it's rolling deployments. And this is part of why the controller manager is in charge of that process, because this has to be a flexible process that cannot be done by a human. It can't be done manually, because at scale it just becomes way too dramatically complex. And so the controller manager is like our ever-watching robot overlord who enforces the state in our cluster. And then last of all, you may notice there is one more big blank spot on our canvas that hasn't been touched yet. So we're still missing one more component of our cluster. And so exactly what we'll do next is we're going to fill in this blank spot. So I hope that clears up the controller manager a little bit, and you can see that we really have this cube coming together so far. And you can see how it empowers you as a developer or an operator to run container engines and runtimes at a distributed scale. All of these components exist for that purpose, with a whole bunch of other fluff and features for enhanced security, making that a more fun process, and all kinds of other nice and neat things. So let's go back to our terminal and add our last component. So this last component is going to allow the deployment pods that we created to communicate outside of the Docker network the Kubernetes way. So we've exposed ports on those pods. We could talk to them if we wanted to, but we need to be able to do this the Kubernetes way, and I'll explain that a little bit more in a moment. So we are going to create a service now for our deployment. We're just going to call it service test because we're testing the service. This will be a very simple service. You can see here that it's cluster IP type. I'll show you the cluster IP when we create it. And we're selecting pods that have this label, app replica test. You can see way up in our deployment that that's exactly what we have right here on every single one of our pods. So just like this pod belongs to this deployment because of that label, those pods also belong to our service because of that label. So let's create this service. We've created the service here. And then I named the service replica test instead of service test because it's just good convention to name your services by the same pattern you name the pods and deployments that they're connected to. Because, for example, when you do kubectl get service, you know that you're getting services, so you don't need it to say service. You just need it to have something that you can use to identify it with the things it's connected to, so that's why I named it that way. It's kind of a free pro tip there. So here we've got this service with this cluster IP here. And we're going to try to curl this service on port 80 because that's where we'll be connected to Nginx. You're going to see that when we try to do that, it doesn't work. And we could try to do that again for all of eternity, and it's never going to work because we need to set up some component that will handle the networking in our cluster in a way that complies with the Kubernetes networking model. So that component is kubeproxy. And I'll show you how kubeproxy accomplishes that, and we cover that very much in depth in some other training, so I'm just going to brush on it today. And just like everything else, we just need it to talk to the API server because that's where it's going to get its instructions, and that's who's going to coordinate those instructions. And kubeproxy is up and running now. Let's check, see that it's running. It looks good. Again, like everything else, always check the logs. Make sure that you aren't seeing anything you aren't expecting. And everything looks the way that we expect it. We're running in IP tables mode for those of you who, for some reason, are Kubernetes experts and decided to join us today. And now, when we try to curl the service, oh, oops, let me fix that. Let's grab this IP. You can see that we get a response from Nginx. So let's go back to the slides and show you kind of where we're at and update our diagram. So here you can see in our diagram we've added kubeproxy, and kubeproxy is responsible for setting up networking rules on the node itself that it lives on so that the pods can communicate. So in Kubernetes, we have this Docker runtime that was not initially designed to run distributed at scale. Now it can do that. You can do that with Docker Swarm, but we have a Kubernetes networking model that requires us to be able to talk to different pods and different services on this, no matter what pods get replaced by what. You know, the backend service or the service always needs to be able to connect to that backend somehow, some way, even if the actual containers under it change. So in order to accomplish that, let's walk through this process. We've sent a command to the API server to create a service for us, which is now listed in etcd. The controller manager, like it's responsible for keeping track of replica counts, is also responsible for creating endpoints to this service. So it's responsible for recognizing that there's a service that's supposed to connect to these pods, and there's supposed to be endpoints created for them. So next, some endpoint objects are created, etcd. Kubeproxy notices that there's endpoints to these pods, and it creates networking rules on the host itself in the mode that we have it running in that tell things that if it wants to talk to this service, it needs to go to one of these pods. You know, it will route us to the proper end destination, because the networking that we see in Kubernetes is a little bit different from the networking structure that is actually on the host because of our container engine. So let me show you what that looks like. So when we sent our curl request through SSH, we sent a request to that cluster IP, but that cluster IP, if you notice, if you're thinking carefully, does not correspond to a specific pod, but that's the IP that we think we're supposed to talk to the pods through. So these networking rules are going to route us to an IP address that will get us in touch with one of those pods that is running on that Docker network. So you can see here that we've got this kind of small sort of network overlay type thing happening here, where we can abstract away the complexity of all of these pods shifting and changing constantly on a daily basis. And this allows us to abstract away the complexity of running so many containers, which can be unpredictable. They constantly change. They're way too volatile to handle the networking manually. So you can see that just like all of the other components, kubeproxy enables us to run the container engine on our cluster. It allows us to run a distributed container runtime on different nodes. And you can see that if we want to do that, we could, for example, add in the network overlay to connect different nodes and abstract that networking a little bit more and allow things to talk to each other node by node. And since, of course, we're only doing one cube today, we're not going to install an overlay network. Also, we're out of room on our diagram. But you can see that all of this stuff contributes to the facilitation of our end goal, which is run distributed container runtimes. Do it in a really clever way, and then Kubernetes adds tons of features on top. But everything we did today just fulfills that bare minimum, that minimum viable goal and mission. So let's go back to our terminal just one last time and clean everything up. So exit out of our VM. This is how you will clean everything up when you're done, if you want to clean everything up. And again, I'll include instructions in the demo on how to do that. This way I can just show you what it looks like so you know what to expect. Then I'm going to run these commands. And say yes. And going to remove this box. All right, and then go up here, remove our folder, and that's that. That concludes all of our work in the terminal.